Hi, good morning to everybody. Lecture 1 for IC application subject, that is integrated circuit applications. The first lecture is block diagram representation of operational amplifier. It's working. An operational amplifier consists 4 blocks. The first block is input stage, second block is intermediate stage, and third one is level shifting circuit, and last one is output stage. Here, these 4 blocks are cascading. Block, that is input stage, consists 2 inputs and 2 outputs. Here, what are the inputs of the first stage? Those are nothing but inputs of the overall operational amplifier also. And the second stage, that is intermediate stage, it consists of 2 inputs and 1 output. And third one input and 1 output. And fourth, last stage, output stage, consists 1 input and 1 output. The output of the output stage of fourth block is nothing but the output of the overall operational amplifier. So before going through block diagram, first of all, we must know about what is meant by an amplifier and what is meant by differential amplifier and what is meant by operational amplifier. The first one, what is meant by an amplifier? An amplifier is an electronic circuit which is used to increase strength of the input signal. So an amplifier is an electronic device which is used to increase the strength of the input signal. Then next one, what is meant by differential amplifier? A differential amplifier is an amplifier which is used to amplify the difference of 2 input signals. So a differential amplifier is an amplifier which is used to amplify the difference between 2 input signals. Next, third one, operational amplifier. An operational amplifier is an amplifier which is used to implement many mathematical functions such as integration, differentiation, summation, subtraction, multiplication, division. Now, we'll go through one by one operational amplifier 4 blocks. The first one is input stage, second block is intermediate stage, third one is level shifting circuit, and fourth one output stage. Now come to the first one, input stage. The input stage is a dual input balanced output differential amplifier. So up to now we know about differential amplifier. Now we must know about dual input balanced output, dual input unbalanced output, single input balanced output, and single input unbalanced output. So what is meant by dual input and balanced output? Within the differential amplifiers, if the differential amplifier consists 2 inputs, then it is known as dual input. If it consists only 1 input, then it is known as single input. If the differential amplifier consists 2 outputs, then it is known as balanced output. If the differential amplifier consists one and only 1 output, then it is known as unbalanced output. So based upon number of inputs and outputs, differential amplifiers are classified into 4 types. The first one, dual input balanced output differential amplifier. The second one, dual input unbalanced output differential amplifier. Third one, single input balanced output differential amplifier. Fourth one, single input unbalanced output differential amplifier. In these 4 differential amplifiers, within the operational amplifier, the first stage is the first differential amplifier type, dual input balanced output differential amplifier. So the first block of operational amplifier is known as input stage. That input stage is nothing but a dual input balanced output differential amplifier circuit. Differential amplifier is a basic building block of an operational amplifier. The function of the differential amplifier is to amplify the difference between two input signals. It also establishes the input resistance of the operational amplifier. So here, this is the first block. It consists of two inputs, two outputs. This is the internal circuit diagram of dual input balanced output differential amplifier. So here it consists of two transistors. So with the two inputs at base terminals of both the transistors, we need to apply actual inputs. Now the output is taken between two collector terminals. So here two inputs are applied and output is taken from two output terminals of both the transistors, okay, at both the collector terminals. So this is the dual input balanced output differential amplifier circuit. Next, the second block of the operational amplifier is known as intermediate stage. The intermediate stage of the operational amplifier is another differential amplifier which is driven by the output of the first stage. So from the four types of differential amplifiers, the first type dual input balanced output differential amplifier is used within the first block, and the second type of differential amplifier, that is the dual input unbalanced output differential amplifier, is used within the second block of the operational amplifier. So the second block, that is the intermediate stage, is usually dual input unbalanced output differential amplifier. These two are cascaded, that is directly coupled. So this is the second block of the operational amplifier, which is known as intermediate stage. It consists two inputs, one output. So this is the internal circuit diagram. So this is the dual input unbalanced output differential amplifier. Two inputs V1 and V2 are applied here to both of the base terminals of transistor Q1 and Q2, and the output is taken from one and only one collector. Dual input unbalanced output differential amplifier. Now come to third block of the operational amplifier, is nothing but a level shifting circuit. A direct coupling is used between first two blocks. That is, the first block is dual input balanced output differential amplifier, and second block is the dual input unbalanced output differential amplifier. These two are directly coupled. That is, the output of the first differential amplifier is directly connected to input of the second differential amplifier. So a directly coupling is used. The DC voltage level at the output of the intermediate stage is well above ground potential. So due to this direct coupling of the first two blocks, certain amount of undesired DC will present at the output of second stage. Level shifting circuit is used to shift the DC level at the output downward to 0 with respect to ground. So here, what's the role of level shifting circuit? It is useful to nullify the undesired DC at the output of the second stage, second block. A multi-stage amplifier with a desired gain can be obtained using direct connection between successive stages of. Here, why we are using direct coupling between two differential amplifiers? Of course, you see here, two or more number of amplifiers, any type, are cascaded. We simply call it as multi-stage amplifier. So here, a multi-stage amplifier is used within the design of operational amplifier. That is, first two differential amplifiers, or first two blocks, are nothing but two types of differential amplifiers. Those are directly coupled. That arrangement, that combination is simply known as multi-stage amplifier. So what is the purpose of multi-stage amplifier? You see here, what's the specialty of multi-stage amplifier? A multi-stage amplifier with a desired gain can be obtained using direct connection between successive stages of differential amplifiers. The advantage of direct coupling is that it removes the lower cutoff frequency imposed by the coupling capacitors. The differential amplifier is capable of amplifying DC as well as AC input signal due to this direct coupling. So here, this is the third block of the operational amplifier, which is known as level shifting circuit. So this is the actual internal circuit diagram. So this circuit is useful. How much undesired DC is present at the output of secondary differential amplifier, in order to nullify that one, okay, this circuit is much more useful. Next, the last one, fourth block of the operational amplifier is the output stage. The output stage is generally a push-pull complementary amplifier. The output stage is increases the output voltage swing and raises the current supplying capability of the operation. It also provides low output resistance. The actual circuit used could be an emitter follower. So here, in place of complementary push-pull amplifier, an emitter follower circuit is also best suitable in place of the fourth block of operational amplifier. The output stage should allow the operational amplifier to deliver several milliamperes current to load resistance. So this is the fourth block of the operational amplifier, which is known as output stage. So this is the circuit diagram. This is the emitter follower circuit, which is known as common collector amplifier. Or instead of this one, we can use a complementary push-pull amplifier also. Both are useful. So anyone we can use in the design of operational amplifier. So this is the entire circuit diagram, internal circuit diagram of operational amplifier. So here, first two circuits are two types of differential amplifiers, and third stage is the level translator. Fourth one is the push-pull amplifier circuit. Thank you.